Our first panelist for this session is Mr. Chawda, Head of Engineering PhonePe. He is responsible for building and scaling data centers for the organization and has been with the company since its inception in 2016. May I request Mr. Chawda to kindly come on stage, please? So we have our second panelist who is already here with us on stage, Mr. Xavier Kurian. He has over 21 years of experience in the IT industry with skills spanning across enterprise architecture, data center design and optimization, consulting and building technologist teams. He also has in-depth knowledge with respect to the Indian enterprise market and trends across the university. And as you can see, our moderator and chairperson, Mr. Sharad Sanghi, is already here with us. Mr. Sharad Sanghi heads the global business of data centers and marine cables of NTT Limited across APAC, EMEA, India and US. He is responsible for scaling the entity. Mr. Sharad is also the managing director of the India business for NTT Limited. He is a pioneer in the Indian cloud computing space. Mr. Sharad is an industry veteran with over 30 years of extensive experience. And now, ladies and gentlemen, I will hand over the session to our chairperson and moderator, Mr. Sharad Sanghi. He is into this panel discussion, efficiency and sustainability in data center design or IT infrastructure. Over to you, sir.
So first of all, thanks to Anand Bazar Patrika for allowing us to have this panel, and also congratulations to them for completing 100 years. So just as a context setting, I just wanted to quickly introduce what NTT does. NTT provides not only data center services across the country, but also network services, system integration services, managed services, cloud infrastructure services, and also now with the integration of NTT Data, application services. So we are the only truly end-to-end company that provides a full stack of IT services in the world. So with that background, I'll just start on the topic itself. So the topic is efficiency and sustainability in data center and IT infrastructure design. And with me are two very esteemed panelists. We have Chawda from the CTO of PhonePe, and we also have Xavier Kurian, who's led the design that we're going to talk about from Dell. Okay, so just a couple of other points of context. One is NTT as a global business, has aligned itself along for sustainability is one of the key pillars for us, and we've adhered to goal number 11 of the UN Sustainability Development Goals, and that is to build sustainable and smart cities across the world. And in addition to that, we've also made a plea that we will become carbon neutral across all our businesses by the year 2030. So very quickly, we've joined many companies like Google, Microsoft, SAP and others towards adhering to UN sustainability goals. Also, just in terms of data centers, we design next generation data centers that are secure and green, and of course resilient data centers. And just in terms of green data centers, before I open it up to the panel, we have optimized power management, renewable energy sources, highly energy efficient equipment, a lot of which we'll be talking about today. We align to ASHRAE cooling standards. Most of our data centers are platinum or gold LEED certified, and this results, all these measures result in lower PUE, lower operating cost, being environment friendly. And one of the good things in reducing the carbon footprint, one of the good things in this is that it's a win-win. So the environmental goal or the sustainability goal is also a business goal of being more competitive and making it more cost effective for our clients. So that's the context, and now I'll quickly introduce our panel. And on my right is Chawda. So Jay, Entity, PhonePe, Entity and Dell, along with our design consultant Sudlos, decided to pioneer the concept of liquid immersion cooling and DCLC in a production data center environment. So Jay, first to you, in the fintech industry, how critical is sustainability for your business?
Thank you, Sharad. So I would take it this way. Sustainability is not just the responsibility for fintech as a industry. I would say for any ethical organization, sustainability comes as something they should look into. Now, taking PhonePe into account, for us the motive or the goal is to go green while providing the best experience for our customers and giving them the maximum value.
Thanks, Jay. Xavier, now to you. As a voice for alternative cooling technologies, can you tell us about the work Dell has been doing and the options that enterprises can consider? And for the audience here, I'm talking about liquid immersion cooling, DCLC, these are all buzzwords. Can you just explain that to the audience,
Absolutely.
what exactly that is?
And thanks, Sharad, for this. So Dell as an organization is extremely committed to its what we call ESG goals on sustainability and what we do to give back to the environment. Now, we've done a ton of things over the years to go and towards that goal. For example, we brought in titanium-rated power supplies. It's 2% extra efficiency, but it's that 2% that you're giving back to the environment. We've also brought in technologies like multi-vector cooling that use air, but it uses the right amount of air that is required to cool a specific component. The next step to all of this was what we call alternative cooling. Now, this has been done elsewhere in the world, and we realized that India was the right place to go and bring some of these technologies. Let me explain what it is first. So, air is a bad conductor of heat. All of us know this. What DCLC aims at doing is to find the hottest components within a server and use a coolant to cool that portion, which means that you have pipes going into the server. It runs through a heat sink, which takes out the heat using that coolant. And you can cool some portion of the server using DCLC technology. The next evolution of that is what we call LIC, or liquid immersion cooling. And as the name says, it's about taking a server and immersing it inside a dielectric liquid. It's not as simple as taking any server. There is some amount of work that needs to be done on the server for it to be able to work. But instead of having racks that are vertical, you have racks that lie down, that are filled with a dielectric coolant, and the server is dipped in and works perfectly immersed inside that liquid. That liquid can then be cycled through a heat exchanger to take the heat out of the data center. So interesting technology and very efficient at cooling.
Fabulous. Thank you, Xavier. Jay, first of all, you talked about going green, right? That's one of your goals. But on this initiative, it had never been implemented before, right? And nobody had done in production. Had done liquid immersion cooling. I think there were some elements of DCLC that had been done, but nobody really did this, and we did a blended setup. So how did it shape up, and what helped the management decide? Because you ended up investing extra capex to go green, and obviously the returns would come over a period of time. So tell us a little bit about how did you guys go about thinking this? Because really, to make it very clear to the audience, it was really PhonePe who decided that they wanted to try this new technology. All of us had read about it. Every server vendor, including Dell, would tell us, that look, the new wave is liquid immersion cooling, etc. But nobody had the guts to do it. But PhonePe actually had the guts to put money where the mouth is and actually implement it. So just would like to know the thought behind it from the management perspective.
Sure, Sharad. So just to give you a slightly broader view, so we are still growing. Like India is a huge marketplace, and we are constantly evolving to add new and new offerings for our customers, our users. And give them a better performance and better avenues to explore this fintech space. Now, when we do that, our fundamental resource that is needed to enable us to offer new and new offerings is servers. Now, we are constantly adding more and more footprint to our infrastructure. With that in picture, we are currently at around 15,000 servers running. Now, this requires us to have much more denser deployments. When I say dense, the requirement of space and power both comes into the picture. Now, given the situation in which, geographical situation in which India is right now, we have an acute problem of power. It's not that power is readily available. Climate is not very favorable for very dense deployments, because as you start scaling up and go into newer technologies, like we were on Intel Skylake series of processors. Now, as technologies keeps on going ahead and ahead, the processors also keeps on getting innovated, and the heating requirement and thermal cooling requirement keeps on going up and up. Now, with that coming into picture, the ideal solution that we thought of is to innovate on how do we efficiently cool our systems. And with that thought process in mind, the solution that came or stood right in front of us was the liquid immersion cooling. We partnered with Dell, we partnered with you guys, and we figured out that this might be or this can work out. And we took a leap of faith over there. We made a case in front of board. So again, like any other company, we have a board and we have investors to answer to. So we made a business case, projected our ROIs, and numbers looked feasible. And with that in mind, we started evaluating and implementing the liquid immersion cooling setup.
Thanks, Chair. Xavier, give us your perspective on how this design and this green data center came about.
So, PhonePe's initial brief to us was how do we go save power? How do we reduce our carbon footprint? And there's a lot of technologies that we can use towards that. But what we realized is that given where India is, it became extremely important to go find a different way of taking heat out of that data center. I remember, it seems like a long time ago, but I remember the early conversations where we were bouncing ideas off each other, and Sudlo's as a consultant that was there, and it was an engaged process to go and try and figure out what can we do. Immersion stood out as a clear, most efficient method of doing it, but immersion doesn't work for everything. There are some types of workloads that you just cannot immerse, and therefore we decided to do a mix of three technologies. There's some amount of air cooling. There's about 35% of DCLC, and about 35% of the environment is immersed. Now you should understand that this is 4.8 megawatts of IT power. This is quite a bit of equipment that is running in there. And setting this up was quite a challenge. It took a lot of collaboration. It took weekly catch-ups. I think it took a lot of leadership, commitment, and the willingness to work through those problems. It absolutely would not have happened without it.
Yeah, and I can't tell you how apt this is to the theme of this conference, because theme is the age of the change makers, and I think this is truly a change-making experience that we've all gone through. And it also aligns with entity's history of pioneering new technology to support the client's business. So here it was as PhonePe's initiative along with Dell, and we had an existing data center already set up, so we had to retrofit that. We had to make some alterations to do this, but it was a great experience for us as well. And the results have been extremely encouraging. We are, and we are looking at what we did also was we set up a proof of concept lab in Bangalore first before we deployed this in production. So we got all the chinks ironed out, and we've shown that lab to like hundreds of clients.
Yeah.
Right. So for us also it's been great because a lot of hyperscalers. It's even more efficient than their designs. They are the ones that are trendsetter. They are the ones who are pushing the envelope in reducing the power usage efficiency. But a lot of them have also come and seen the design. So, you won't be surprised we'll start getting a lot of calls, Xavier, for more business.
I think that POC environment was the proof of the pudding. The first time we set that up, even we were a little, it's been done outside the country, but can we make this happen? So I think that was the key to it.
So to both of you now, first Jay and then Xavier, this project is clearly an industry first, right? There's not been anything like this in the country, and in fact, I believe Burzin was the one who said that the Intel CEO actually in his earnings call referred to this project, called us out. Tell us about some of the learnings that you've encountered, because many in the audience may want to actually implement this in the future. So what are some of the learnings? I would ask both of you turn by turn to answer that.
Sure, Sharad. It's a very interesting question. So while we decided to do LIC, or that is what we call it, liquid immersion cooling, the intention was right, but timing didn't fit well for us. For a specific reason is we kicked off this project and COVID hit. So we did face lot of logistical issues, lot of manpower issues. What worked out well that time for us was the consistency in the team that was involved in making this a reality. Like hats off to Entity for sticking with us, making sure this gets delivered. We had some hiccups in start, but then we delivered this project right on time. Learning wise, as we say, there is not a single size that fits all. The standard air-cooled setup in today's industry is pretty much hardened. Everybody knows what to expect, what not to expect, how a particular component is going to behave in that environment. When we went into LIC or liquid immersion cooling, we discovered a lot of surprises, right from the part where when we immerse a power cord into a liquid, the behavior of the casing of that power cord is going to change and it might get brittle. Fiber optics does not behave in the same way it behaves in an air-cooled medium as it will behave in your liquid immersion cooling setup. Our typical operations on our servers, for example, all our hard drives are hot swappable hard drives. When we decided to do liquid immersion cooling, the way in which servers are mounted is generally power goes up and hard drives goes down. If you do that in liquid immersion and you immerse the server, if I want to do a service of the hard drive, I have to take the entire server down. Defeats the purpose of hot swappable drive. So we had to redesign the entire process in which the servers are mounted, redesign the racks in which the mounting happens. Interesting findings that we saw is the failure rate of the servers drastically reduced. There is a lot of reasons behind that and we'll cover it further in this session, but another important learning that we got is how well Indian tropical climate, even though it is generally warmer than rest of the places where data centers are deployed, since we use water as the medium to cool the cooling medium of the liquid immersion system, your ambient temperature is just about enough to cool it. So our power requirement went drastically down when we moved to an LIC-based system. Xavier?
Xavier, from your side.
See, this was the first immersion setup that we did in India. And while it has been done internationally, and we could talk to a lot of my colleagues outside in the Americas and Europe that they'd done it, we learned a lot from them for the initial stages. Then we learned that India is a very different place. You have to train the people that have to go manage those servers. You have to train the people that are going to deploy the immersion, the equipment itself. You have to make servers ready to be able to be immersed. You can't just take any old server and dip it inside. For example, servers have to work without fans. In a traditional environment, a single fan goes down, you get system alerts saying that, hey, something's wrong. And you've got to get a full server to work without fans. So it's not just the learnings on the DC, but there were learnings on IT infrastructure, how we arranged network, how we cabled the entire thing, and every one of those things was a phenomenal learning by itself. It was and at this scale, it was quite a challenge. And I know that we needed a lot of help to get through this, and the folks at PhonePe were very amenable, and your teams as well were absolutely on the ball.
Thank you, Xavier. So Jay, ever since, now it's been a few months, more than 6 months that the data center has gone live, has your application performance been negatively impacted in any way, or and tell us about the biggest benefits that you're seeing since it's gone live?
Sharad, I'm going to take this by risking taunting Murphy's Law. So, fingers crossed, but so far we haven't seen any negative impact. The impact that we have seen is, like, I would take it in this way. The biggest, like, we all are here because of the air we breathe. But this same air is the reason why most of your electronics fail. When we did liquid immersion, you took air out of the equation. It's completely oil. So as soon as you dip or immerse a server in a liquid medium or an oil-based medium, your risk of corrosion, your risk of any kind of contamination goes away. With that, your lifetime or the mean time between failure of server significantly improves. And we saw it happening. We saw a great increase in the stability of our systems. With that in place, another important factor, like in my early days, I used to sit out of a data center and work. And for all you have been in a data center, you might realize how noisy it can be. And with liquid immersion, it's pin drop silence. Like, it's like a hall full of tens of thousands of servers and no noise at all. And that's a pleasurable environment to work in. So yes, no negative impacts. We started seeing great ROIs in terms of stability of the system. When your temperature of your entire system is at a stable or a optimal range, your servers or your systems automatically start to behave in the way they are supposed to behave. Like if there are sudden fluctuations in temperature or thermals, your application, your systems will not behave in the way they were designed to behave. But when you put it in a medium which regulates the thermals of your system, everything starts behaving in much more deterministic way. So that was the biggest takeaway for us, that once we started seeing this result, we are like, okay, we have done the right thing over here.
Excellent. Just for everybody's background, and maybe I should have done this earlier, 10 years back when we designed data centers in India, with the Indian climate like Bombay and other places in India, the PUEs that we would see in the market were in the range of 1.7 to 1.9. Most designs today, the PUEs are in the range of around 1.4 to 1.6 today. But with this technology, in this blended PUE, designed is 1.27, but the liquid immersion part, Xavier, would be around 1.1. Yeah, and the DCLC part would be around 1.3 and 1.28 or so, and then the normal cooling would be around 1.5 or so. So the blended PU in this 30% design that Xavier mentioned, we've got roughly one third of all three technologies in one room is around 1.27. And now in future designs, PhonePe and hopefully other clients will also look at more of LIC so that the PUE can come down even further. So Xavier, there are many in the audience who may want to go green in their data centers, right? Not only they've heard this talk that it's actually possible to do liquid immersion cooling, but there are a lot of other measures that they can take. So what are the key things that businesses should consider while evaluating green data centers for themselves?
So the first thing I want to say is that very rarely in life does doing the right thing and the best thing for the organization work together. Alternative cooling is one technology where you can do the right thing for the environment and save money. Normally, if you wanted to do the right thing for the environment, you're going to be spending a little extra money. This is one technology which the ROIs work out in about 3.5, 4 years, and it can pay you back over the life of the data center, which is about 10 years. It's the other piece that I want to bring out, and this is to the audience that wants to try this. The recovery of that money happens over OPEX. And unfortunately in our industry, very often CAPEX sits with IT and OPEX sits with facilities. So it's important to start looking at this as an overall environment and start seeing where is it that the net savings can happen. The other piece that I want to really call out is that experience in this really matters. We thought that with all the experience and learnings that we had globally, with a lot of people explaining it to us sitting outside the country, we thought we could pull this off, and it was a big learning curve. Find the right partners, find the right people to help doing this, and experience really matters. The environment in India is absolutely right for it. If there is an aim to go save net power, to reduce your carbon footprint, and you are using a fair bit of power in your data centers, this is a technology that can definitely save that a fair bit of that environment. Sharad, you were saying that 1.5 to 1.6, this effectively means that 60% of your IT power is being used to cool. If you can get that down to 1.27, you've just saved 30% of the of your
energy
data center of the power you're using to cool. Which is the right thing to do as well.
Absolutely. Jay, your advice, I know Xavier just mentioned about what people should consider, but what is your advice? You took this ambitious task of doing this, and what is your advice to other potential enterprises who are planning their own green data center?
So my advice from learnings that we had is start small. Iterate a lot, learn from the process. But most importantly, choose the right partners you work with. Because those are the people who will help you see it through. We partnered with NTT, we partnered with Dell, and we got good results. When you are trying to venture into a unexplored territory, for us, liquid immersion in India is an unexplored territory. We gave a wide range of thought on how to do it, how not to do it, what can go wrong, what will work. And still after that, after doing great amount of groundwork, we still had surprises. So yes, the choice of partner matters. Starting small does matter. Like we did a small POC, ran it for a few months in Bangalore. It worked out well for us, and then we decided to make a bigger investment in OPEX and CAPEX, and then go ahead, do a wide-scale deployment. Places where this works out well, as per my experience, is if you are doing a greenfield setup, like you are starting up fresh into a new facility, liquid immersion is probably the better choice to go with. If you are doing a retrofit, like you don't want to invest into tweaking into your servers, just want to do minimal changes to your server and get things going, DCLC or direct contact liquid cooling, which is the second technology that we implemented, will work out best. The scenarios where the alternate cooling, or when we say liquid immersion, will work well is the conditions where you have micro pop kind of an environment, where you have to set up something small but spread across wide area. Like a micro edge or a micro DC, this will work well. Or if you are doing a large data center deployment, tens of thousands of servers, or at least more than 5,000 servers, for example, this will work out really well for you. If you are doing a mid-sized deployment, I would say this might not be the right time for it. But having said all those things, my opinion is this is primarily a initiative towards giving back to the environment, and for that to happen, the colo providers like NTT played a big role for us, and this infrastructure providers will have to scale up the capabilities and build processes around this so that enterprises like us can come and easily adopt these technologies.
Thank you, Jay. Now to both. First, since Jay just went, I'll go with Xavier. Looking to the future, what technologies, in your opinion, can even further improve the PUE, or how can you make it even more green?
See, LIC, immersion cooling, is actually really efficient. It can achieve a PUE of 1.1. Very simply, you've got oil that's sitting at about 40, 42 degrees. It's nice and warm to touch. That is being cooled. Now, cooling something from 42 degrees or 46 degrees to 42 degrees is insanely efficient. So LIC is a very efficient system. Now, there are other technologies as well. So fresh air cooling is fairly popular in some of the Scandinavian countries, for example. But in India, air quality and outside temperature typically play spoil sport there. Long term, if you look at it, the technologies exist. The adoption and what works in India is fairly critical. Outside of cooling technologies, there are other technologies as well. For example, compute is switching from traditional CPUs to alternative methods of arriving at that same capacity. FPGAs and other accelerators are a good example. There's a lot of improvement happening on the application side and the platform sides as well that are improving efficiency. So efficiency of a system is more the entire ecosystem. Efficiency in cooling, how you arrive at that efficiency, but also look at other forms of efficiency, and we look across the entire spectrum.
Awesome. Jay, from your perspective, the future, what does the future hold for making it even more energy efficient?
So Sharad, as we know, this industry is constantly evolving. Like 10 years back, probably liquid immersion or DCLC would have been something that a research institute might do, or a university might try it out, or probably a PhD student will experiment with it. Having said that, now that LIC is in place, there are newer and newer technologies coming into mainstream, like we have piezoelectric cooling, we have nano cooling coming into picture. All of this, once they become mainstream, we will see much and much better utilization of power available for us. More and more research is going into efficiently designing the microprocessors and systems so that the heat dissipation is low. So it's going to be an interesting time when we go ahead to see how far we can go. Of course, you cannot go below 1, but as close as possible, we'll try to be there.
Thank you both so much. But before I summarize or conclude, I'd like to open it up to audience. If you have any questions on this technology, we've got two experts here, who've designed this. One of the first. I don't think anybody's deployed 4.8 megawatts of liquid immersion cooling and DCLC in the country. I think very few even in the world in third-party data centers. And so if there are any questions, if you are curious about this technology and how it is adopting, we'll be happy to answer.
Shall I?
On an average.
Yeah.
So the cubic, it's not about cubic meters, it's about temperature, right? So the way the system works is that you take a server, you immerse it inside a dielectric oil, and that oil needs to run between 38 degrees and about 42 degrees, 45 at outer extreme. That oil is then transferred into what we call a CDU, a coolant distribution unit, which has both the coolant and water flowing through it. And the water is then carried to the roof into a dry cooler. Now, each of those tanks, which have about 48 servers, has about, I'm going to say about 300 liters, and don't hold me to that, of oil in it. And there are servers immersed inside.
48 servers. 48 servers
are submerged inside each tank. Now, the question to ask is not how much oil is in that tank. The question to ask is how fast the oil is flowing. and the oil flows at, the oil circuit flows at about 0.7 liters per second. The water circuit flows at about 32 liters per minute. So, and that's the factor of how much heat you can carry out. What you should remember is that oil and water are far better, have a much higher calorific value than air, and therefore the total amount of heat that can be carried out by a liquid is significantly higher than what air can carry.
So just to answer your question, it's not about how many kilowatts you need. The oil is never getting spent that fast. It's a circulation loop. So your oil gets heated up, it gets cooled and comes back to the same tank. So the lifetime of the oil, if I'm not wrong, is 5 to 10 years. So once you fill up your tank, so if your tank is say 1,000 liters of tank, for 10 years you don't have to look at it again. You fill it up. It's similar to how your car's coolant works, right? Till your coolant dries up, you don't have to look at it again. The same way, till your tank oil is there and it is giving the same thermodynamic capabilities, you don't have to look at it. You just have to cool the oil so that it starts cooling your server.
And in which organization you have implemented this at Bangalore?
Again, please.
At Bangalore, you have implemented this project.
Yes, we have a proof of concept, so we are happy if you want to come and see it. We'll be happy to show it to you. It's in production, but it's in a small room that we first tried that out. So they actually have production servers, but with their permission, we can show it to you.
This is in a POC stage.
No, it is production. The LIC is a POC state, but the DCLC is in production in Bangalore. So we have a small room where we've implemented it. In Bombay, where they've put at 4.8 megawatts, that is something we can't allow visitors because that's, that's production. But in the Bangalore data center, we're happy to show you if you would like to come and visit.
Okay, thank you. Thank you very much.
Any other questions? Okay.
Good afternoon. My question to Mr. Jay, how many of these centers are you planning? And are they exclusive data centers for PhonePe or is it for others also?
So we are present in 3 data centers, and all 3 as of now are co-located by NetMagic or entity, and the halls are typically exclusive, but more details Sharad can provide.
Yeah, so the way it works is that they have exclusive server hall areas. So even though it's a multi-tenanted data center building, but that particular floor or server hall is exclusive to them, because in other halls we may use other conventional technologies, because not all clients agree, because they have to change, as Xavier was mentioning, they have to change the servers they use. The standard servers and standard networking equipment may not necessarily work in a liquid environment. So what we've done is we've given a complete dedicated server hall where they've deployed this technology. And in future deployment, they're doing another deployment in the next data center with the same technology. That should go live sometime mid next year.
Okay. And when are the commercial centers opening? The liquid emulsion controlled centers? Like you mentioned, right now it's at POC stage. So when are you opening them commercially?
No, this is live. Sorry, the Bangalore one, I was talking to the gentleman that the Bangalore one, before we went production, before we went production, we did a POC in Bangalore. That is something we are opening it out to others to take a look. But the production data center went live 7 months back.
Okay.
So it's actually in production, right? 4.8 megawatts deployed in production.
Thank you.
Thank you. Okay, I think that was a bell to signal that we're out of time, so I don't think I can take any more questions. But I'd like to thank both Jay as well as Xavier for sharing their insights. First of all, to Jay and to PhonePe for having the vision and to be a true change maker in coming up with this concept. We all, as I said earlier, we'd all heard about it. We've heard Microsoft has got data centers under the sea. We'd heard, we had seen videos on YouTube of people immersing servers, but never thought that we would actually do it, or we would convince someone that we could do this. And it was actually great to actually get this, not from our side, but actually from the client side, asking us to do something like this. So thank you, Jay. And thank you, Xavier. Xavier is actually the champion who actually really put everything together. So it was NTT from a data center perspective, it was PhonePe from a compute perspective, it was, Sudlos from a design engineering perspective, but really Xavier got everything done together and, came up with this solution. One of the best guys I've come across in the industry in this space. So thank you, Xavier, for coming here. And thank you, everyone. You've been a great audience. Just to summarize, from PUEs of 1.4 to 1.6, you can actually achieve a PUE with pure LIC, even in a climate like India, below 1.2. And so keep that in mind when you're designing your next data centers, and go with experts like Xavier and hopefully us when you choose your partners. Thank you so much. You've been a great audience. And thank you especially after such a great event from Gavaskar and Vishwanath that you stayed back. We're really deeply grateful. Thank you so much.
Thank you very much, sir, for moderating and chairing that very interesting session. Thank you, Mr. Sharad Sanghi. And of course, our panelists, Mr. Jay Chawda and Mr. Xavier Kurian. Thank you very much. May I request Mr. K.K. Mahapatra, Head of Infocom, to kindly come forward and present mementos to our chairperson and moderator and our two panelists. One minute. Mr. K.K. Mahapatra will be here to present the mementos. Thank you very much, Mr. Jay Chawda, for that interesting and interactive session. Thank you very much, sir. And a round of applause, please. Thank you to our chairperson and moderator. Thank you, Mr. Sharad Sanghi, for that interesting session that you moderated and chaired. Thank you very much, sir. And thank you, Mr. Xavier Kurian. Thank you, sir.